All right, so we've already talked about drawing ray diagrams for mirrors. So now it's time for us to shift our focus to talking about ray diagrams for lenses. So what I have here is a convergent convex lens. And we are going to see how light passes through our lens. Okay, so before we get into too many details about how this whole process works, right, I want to show you what the different parts of a diagram like this are. So if you can recall with our mirrors, we had a normal line. We had a point of focus where all the light would like bounce towards after it reflects off of our mirror. And then we have a center of curvature, which is essentially the middle of that circle. And then our object, we just use an arrow for reference. Okay, so similar setup, but for lenses, we've got twice the amount of curves, right? So therefore, we'll have twice the amount of foci and centers of curvature. So imagine here we still have our objects that we had previously. And if light is coming from where the object is, right, we are going to have two separate curves that light is going to have to pass through. So our first curve, this guy right here, this is going to be our primary curve in the lens, has its own focus, and that is going to be in towards the center of that circle, right? So our focus is going to be half of the distance from our primary center of curvature. So here's our first circle, right? The orange guy here. This is going to be the center of that circle, and then half of the distance to the center is our focus. That is where the light is going to cross through. After we have made it through our primary curve in the lens, we're going to make it through our secondary curve, our second curve, which I have in here on pink, or with pink. So similarly, we have our center of curvature, the middle of this circle. If you imagine this is going all the way around. And then half of that distance is going to be our focus, or more specifically, our secondary focus for that secondary curve. All right, so now we've got all of this craziness identified. It's time for us to get started with creating our diagram. So very similar to how we worked with mirrors, with lenses, we are going to have two different lines that we're working with. The first one is going to go from the top of our object, and it's going to ride parallel to the normal line. And it's going to go to the middle of our lens. So it's going to go through through our first curve, and it's going to refract. So it's going to go through, it's going to refract, it's going to essentially bend towards that primary focus. So I'm going to draw my dotted line just to show difference. It's going to go through that primary focus. But here's the thing, is that when you have a lens, unless it is perfectly translucent, perfectly transparent, you are going to have some reflection that happens as well, okay? You can choose to draw this, or you can choose to ignore this part here, because our real focus here is going to be on the refraction through a lens, okay? The second line that we have is going to go from the top of the object through the secondary focus back to that center line. So we're going to go from the top of the object through the secondary focus to that center line. All right, I really should be using a straight edge, but I think the point is still pretty clear. Okay, so again, through that secondary focus, it's the focus from that second curve. right? And then it's going to refract parallel to our normal line. That creates our image right here, right where this intersection is. I didn't draw perfectly straight. It would be about here if my lines were straighter. But this is our image. So let's go back to that lost diagram or lost chart. So in lost, we are describing the location, the orientation, the size, and the type of image. So the location of our image, what it is that we see, right, would be here between our primary focus and center of curvature. So I'm going to say between F1 primary and the center of curvature, primary center of curvature. All right. Our orientation, it's going to be inverted. It's upside down. So we're just going to write O is inverted. All right, and we can tell that because it's below that normal line. Our size, if we were to, again, have perfectly straight edge lines, which you'll see better in the computer drawings because that forces you to have the straight lines. But this size is actually going to be reduced. So size reduced. All right, and then T, which is our type. The type for this is going to be real. Okay. Opposite of what we had for our mirrors, where, let's see, where here our real image was on our side, the object's side of the mirror. The real images for a lens are going to be through the lens, because you look through a lens, you look at a mirror. So if the image is here through the lens, if it is refracted through the lens, it is going to be real. If in our mirror, if the image was back here, or technically it would be up here, for a mirror, then that would be virtual. For us here, if the image was behind the lens, like on our side of the lens, or if it was even acting in a goofy way up here, then you would have a virtual image. But here, with our normal line above where our image is formed, and it is through our lens, we do have a real image. All right, so that is what we have for a lost chart and a ray diagram for working with lenses. The quick difference, and this is just bringing this lovely diagram up. Quick difference between where the images are going to be forming for the mirrors that we just, or for the lens that we just drew, which is a convex and converging, is that the primary focus is going to be behind the lens in a convex lens. If we have a concave divergent lens, that primary focus is going to be on our side of the lens. All right, that is all we've got. Have a wonderful day.